So this, you can consider this to be a kind of important problem. Find the maximum profit that a company can make if the profit function is given by Px is equal to 41 plus 24x minus 18x squared. So given here, profit function Px is equal to 41 plus 24x minus 18x squared. Okay. Now x is, in this case, x is what? If the profit function is 41 plus 24x minus 18x squared, in this case, the x is normally in economics considered to be the number of units produced, or also called as the output. Okay. Here they have not mentioned anything. They have only given in terms of x, so it's okay. But normally x is considered as the output or number of units produced. Now you need to find out the maximum profit. That means you need to find maximum px. So first of all, you find out dpdx. You get dpdx as 24 minus 18 into 2x. You get this as 24 minus 36x. Okay. Now for maximum or minimum profit, that is for the turning points, minimum profit, what is the condition? First derivative must vanish. That means 24 minus 36x is equal to 0. Okay, so that gives us x is equal to 24 by 36. Okay. That gives us x is equal to 2/3. Okay, now how to check whether profit is maximum or minimum? Find out the second derivative, d2p dx2. If you see d2p dx2 is nothing but, if you differentiate this one, you simply get minus 36. But at, you need the d2p dx2 at what point? At x is equal to 2/3 d2p dx2. See, d2p dx2 is a constant function, right? So whatever be the value of x, it will remain minus 36. So it is less than 0. That means px has a local maxima at x is equal to 2/3, right? So this is when x is equal to 2/3, the profit is maximum. And what is the maximum profit? Put the value of x as 1/3, p 2/3, put it in the function. If you see, the function here is 41 plus 24x minus 18x squared. 41 plus 24x minus 18x squared. Okay. You simplify this, take the LCM, you will get the value of this as 49. Clear? Move on to the next one then. This kind of problem, as I told you, you will come across later on. Please take note of this problem. Number 5. Question here is, calculate the gradient of the curve x cube minus x square plus 3x minus 1 at the point x is equal to minus 1. Find also the minimum gradient of the curve. Okay. So given here, given equation of the curve y is equal to x cube minus 6x square plus 3x minus 1. Now, the first part of the question has nothing to do with maxima and minima. Okay, you simply need to find a gradient of the curve at the point x is equal to minus 1. Now, if you remember, what first of all find dy dx, gradient of the curve at any point xy, right? If you remember from your chapter on derivatives, when I was discussing differentiation, I told you gradient of the curve at any point xy is, differentiate this dy dx. Let's call this as m. M is equal to gradient m is equal to dy dx is equal to 3x square minus 6 into 2x plus 3, which give you 3x square minus 12x plus 3, which is equal to 3 times x square minus 4x plus 1. Okay, this is the gradient of the curve at any point xy. We need to find out the gradient of the point at x is equal to minus 1. Therefore, gradient of the curve at x is equal to minus 1 is dy dx. Put x is equal to minus 1 in dy dx. You will get 3 times minus 1 square minus 4 into minus 1 plus 1. Okay, this you will get as 18. So, so the gradient of the curve at x is equal to minus 1 is 18. Okay, and the next part states find also the minimum gradient of the curve. Okay, now see what is the gradient of the curve at any point xy here. This is dy dx, right, which is equal to m we have taken. Okay, so let's start with here with this thing, gradient of the curve at any point xy is given by m is equal to 3 times x square minus 4x plus 1. Okay. First of all, find dm dx, which we get thrice 2x minus 4. Right? Now, for maximum or minimum gradient, that is for turning points, for maximum or minimum gradient, we have dm dx is equal to 0. That means thrice 2x minus 4 is equal to 0. That means 2x minus 4 is equal to 0. That means x must be equal to 2x is equal to 4. That means x is equal to 2. Therefore, at x is equal to 2, you can either get the minimum gradient or the maximum gradient. How to check whether the gradient is minimum maximum? Differentiate it once again. d2m dx2. You will get at thrice into 2, which is equal to 6. At we want to check for maximum minimum at the point x is equal to 2. So at x is equal to 2, d2m dx2 is a constant function, so it remains equal to 6, and which is positive, right? So that means m has a local minima at x is equal to 2. And what is the minimum gradient? is equal to, now what is the expression for m? Expression for m is this. Put the value of x here. M is equal to minimum gradient is 3x square minus 4x plus 1. 3 into x square. X here is minus 4 into x plus 1. Okay. Or is it 12x? Okay. Now this is 4x. So this will give you minus 9. Okay. I hope this should be clear. Moving on to the next problem. Prove that uh, the following functions do not have a maxima or minima. First one. Now e to the power of x I had shown you by first derivative test also, if you remember. So I start by saying let fx is equal to e to the power of x. Therefore, first derivative is f dash x, which is equal to e to the power of x, right? Now e to the power of x is not equal to 0 for every real x, right? Also, e to the power of x, the first derivative, is positive for every real x. Thus, e to the power of x is increasing for all x belongs to R. Hence, it has no maxima or minimum. Because the sign does not change at any interval. For all real values, the sign remains positive, okay, of the first derivative. It is not equal to 0. Therefore, it has to be an increasing function. Next is log x. Find out the first derivative. First derivative is 1 by x, right? Which is not equal to 0 for x not equal to 0. And for all other values, what sign is it going to have? For all other values, this is going to have either a positive sign or a negative sign, right? But fx is equal to log x. That means you cannot have x greater than 0. So here, fx is equal to log x is defined only for what interval? 0, infinity, right? Because x cannot be negative. And in fact, it cannot be equal to 0 also. So therefore, this should bracket should also be, this should be an open interval. Okay, 0, infinity. So in the interval 0, infinity, what is the sign of f dash x? F dash x remains positive, right? For all positive real values of x, first derivative is positive. Thus, fx is increasing for every positive real x. Hence, it has no maxima or minima. Okay. Moving on to the next one, if this is clear. 6, 3. I say let fx is equal to x cube plus x square plus x plus 1. You need to show that this function has no maxima or minima. First, find out the first derivative. F dash x is equal to 3x square plus 2x plus 1. Right? Now, if you can show that f dash x remains positive for all real values of x, or f dash x remains negative for all real values of x, then our job is done. So how do you show this quadratic function is either fully positive or fully negative? You take 3 out, write this as x plus 2/3 x plus 1/3, which is equal to thrice x square plus twice 1/3 x plus 1/3 square. That is, you are writing this as a plus b whole square form. Now, because 1/3 whole square, I have given an extra term, I subtract it. And I have this 1/3 already, so I write this back. So what does this part become? This part becomes x plus 1/3 whole square. And this becomes plus 1/3 minus 1 by 9. So thrice x plus 1/3 square plus. Now 1/3 minus 1 by 9 is 2 by 9. Okay. And this is, if you see, x plus 1/3 square is always positive, and you have a positive number added to a positive number. So this is always positive for every real value of x. Right? Thus, f dash x is increasing for every real value of x. Hence, fx has no maxima or minima. Okay. We proceed to the next problem then. The next problem is problem number 7. Also a very important problem. Now look at number 7. Find the coordinates of a point on the curve y is equal to x square plus 7x plus 2, which is closest to the straight line y is equal to 3x minus 3. This is your, suppose, your curve, and you have to find a point on this curve which is closest to, say, this straight line. Suppose I draw a straight line here. What point on this curve is closest to this straight line? There are infinite number of points, but which point is closest? That is, has the minimum distance, minimum perpendicular distance. Suppose if I take this point as P, then this point will have, among all other points, this point will have the minimum perpendicular distance. Okay. This is what we need to find. So I start by saying, let hk be the point on the curve y is equal to x square plus 7x plus 2, which is closest to the line y is equal to 3x minus 3. Okay. So I have taken the coordinates of P as, say, HK. Now clearly this point PHK lies on the curve, right? So since PHK lies on the curve, y is equal to x square plus 7x plus 2. Therefore, you can, this must satisfy this equation. Therefore, you can put y is equal to k and you can put h is equal to x. Okay, this is what we are getting. The first relation. Call this equation number 1. Now, we need to find out the minimum distance of the point, right? That is d. This d has to be minimum. First of all, let's find out the distance of the point. Perpendicular distance of the point P from, let's write PHK, from the line y is equal to 3x minus 3. Let's write it in ax plus by plus c form. Let's rewrite this equation as 3x minus y minus 3 is equal to 0. Okay. Now, if you remember your formula, last year coordinate geometry, distance of the point x1, y1 from the straight line ax plus by plus c is equal to 0. What was the distance of this? The distance here was plus or minus ax1 plus by1 plus c divided by root over of a square plus b square, right? So here, this perpendicular distance, if I use this formula, it is equal to plus or minus. What is a here? A here is the coefficient of x, which is 3. x1 here is the h plus b here is minus 1 and y here is k and c here is minus 3 divided by root over of 3 square plus minus 1 square. This is the perpendicular distance of the point. Okay. Okay. Let's call this P. Instead of D, let's call this P, which is equal to, you will get 3h plus or minus, in fact, 3h minus k minus 3 divided by root 10. This is what you are going to get. Now you see that in this is very important technique which will be applying mostly in the applied problems. Okay. Now see, P is in terms of two variables, h and k, right? We not want to bring this down relation to one variable. So how will we do it? We'll use one. We use the relation between h and k to bring it down to one variable. Now, this is obviously not k squared, this is k. Okay. So we will use this one to bring this relation down to one variable. Instead of h and k, we should have only h. So what are we going to do? We are going to write this as plus or minus 3h And what is the value of k here? H square plus 7h plus 2 minus 3 divided by root 10. Okay, which is equal to plus or minus, you can write this as minus h square minus 4h minus 5 divided by root 10. Okay, this is what we get. So expression for P is this. Now for maximum or minimum P, what is the condition? That is for turning points. We must have dP, and what is the variable here? H, right? So dP dH must be equal to 0, right? If I differentiate this, what am I going to get? Plus or minus 1 by root 10 times minus 2h minus 4 is equal to 0, right? That means minus 2h minus 4 must be equal to 0. That means minus 2h is equal to 2. Minus 2h is equal to 4. That means h is equal to minus 2. Right? So at h is equal to minus 2, P is either maximum or minimum. Now, how do we check whether it is maximum or minimum? We find out the second derivative, d2P dH2. You differentiate this part, plus or minus 1 by root 10 into minus 2, right? Which is equal to plus or minus minus 2 by root 10, right? At h is equal to 2, h is equal to minus 2. d2P dH2 remains the same. That is plus or minus minus 2 by root 10. Now see, there are two signs, the plus sign and the minus sign. So which sign should I take? Any sign that you take, it will remain as your at h is equal to minus 2. Here now, if you take the positive sign, not any sign, if you take the positive sign, this will be negative, right? If you take the negative sign, this will be positive. That means at h is equal to distance is both minimum and maximum. But here they are saying that maximum distance means what can be the distance between a straight line in a curve actually extends till infinity, right? Curve will extend till infinity, right? So what can be the maximum distance? Maximum distance can be infinity, right? So here it is the minimum distance that we are talking about. So therefore, h at h is equal to minus 2, we must get the minimum distance. Understood? The maximum distance can be infinite. So we say thus P has a point of local minima at h is equal to minus 2. Okay. And now because the uh, coordinate has because the coordinate has the x coordinate and the y coordinate, we have only got the x coordinate of the point. How will I find out the y coordinate? I will find out the y coordinate by putting the value of h in 1. So from 1, k is equal to h square plus 7h plus 2. Put h is equal to minus 2 here. Yes, so you get 4 minus 14 plus 2, which is 6 minus 14, which will give you minus 8 actually. Therefore, the required point on the curve which has what is the language in the question, which is closest to the straight line, okay? Which is closest to the straight line y is equal to 3x minus 3 is the x coordinate is minus 2, the y coordinate is minus 8. Or yes, minus 2 and minus 8. Okay, so this was just a hint of one applied problem that I did. We are going to do many such problems in the times to come. So I hope this is clear. We can move on to the next problem. Okay, next problem. Number 8. Question is, find the maximum value of. I start by saying let fx is equal to, or let y is equal to, because uh, we are going to take logs on both sides. So when y is equal to, we have this, then it will be convenient for us. Okay, let y is equal to 1 by x to the power of x. Okay. So what do we need to find here? We need to find dy dx first, right? Because for maxima and minima, dy dx must be equal to 0. But if you see, this function is such a function which is raised to the power of x, right? So that means we take y log on both sides. In order to differentiate this, we'll take logs. We get log y is equal to log 1 by x to the power of x. That means you get log y is equal to x log 1 by x, which can be written as log y is equal to x log 1 minus log x. Log m by n formula. Log 1 is 0. That means log y is minus x log x. Okay. Now, in order to find dy dx, we differentiate both sides. Implicit function, if you remember, differentiating both sides with respect to x. We get 1 by y dy dx is equal to minus, differentiate by u into v rule inside the bracket. The derivative of log x is 1 by x plus log x into the derivative of x simply 1. So you get here minus 1 plus log x. So therefore, what is dy dx? Dy dx is equal to minus y into 1 plus log x. That means now you put divide y is the value of y 1 by x to the power of x to 1 plus log x. Now for maximum, or minimum, y, the first derivative must vanish. That means you have minus 1 by x to the power of x into 1 plus log x is equal to 0. That means 1 plus log x is equal to 0. That means log x is equal to minus 1. And what does log x is equal to minus 1 mean? X is equal to e to the power of minus 1. That means x is equal to 1 by e. So at x is equal to 1 by e, we should get a maximum or a minimum. Okay. So if I call this 1, we need to find out the second derivative. Okay. Now since only 2 minutes are left, so I'll stop here.